due date is 2 o'clock today. No, Eden, we take the organic as taught. Okay, because it was done online. It's what the catch-up will be for. If we have time at the end, we'll revise it again. Okay. Now, with the assignment, some of you have sent me some messages, and I'm glad some of you have done it. Some of you have had heart attacks when you realized it was there. The purpose of the assignment, it's a quiz. It's really just to see how you're doing with Doppler. Are you on the right track? All of that sort of thing. And I'm sure you've seen. So you've written something and you wrote Doppler effect, or you wrote the Doppler effect. I can't reach, and it said it's wrong. Please don't worry about that. Or you wrote it with a lowercase letter instead of a uppercase. Don't stress about that. The way it works is, yes, it's automatically graded, marked by the computer, but that mark isn't final. So I have a way of going into it because it's my assessment. So when everything's in, I can do, and it's all done online. So I can go in. What if you can't answer the first question? Ruth. No, of course you can. You can, Ruth. Use your textbook. Ask for help. No, Electra, I'll tell you now. Give me a second, okay? Electra's quite concerned. It's all right. One thing at a time. I will go back in. Okay, Dr. Google, Kaylin. I will go back in, and then I go and I say, and I see that there's a whole bunch of you that have given the same response, but it's right. I tell the computer, it's all right, Electra. I tell the computer, actually, it's right. Allocate the marks to it. All right, so it'll go back and change the marks. I know there's an issue, I think, with question 8. I will probably have to go back and redo that one, look at it again. We're still learning how forms works. There's still issues with it. But don't stress about it, okay? So the mark only becomes final when I post it back to you. So you will get a notification to say this is your mark. On that as well, I can give, Tyler, I'll get to you. I will give you feedback. So I can go, this is why the answer is wrong. Or this is what you got wrong. This is where your thinking was wrong. So it's a nice way to give you feedback individually, which is actually really, really nice, especially for the multiple choice, because I can tell you what you did wrong in your thinking for the multiple choice if you didn't get the right answer. Tyler and Benedict, it's not for marks for your report. Okay, that's not the point. The point is, if you'd read it, it's a benchmark. It's for you to see how you're doing. It's for me to see if you get in it. Okay, it's not for your report. I can't make it for your report because some of you are going to have done it without looking at your books because you really want to see how you're doing. Some of you will ask people. Some of you will get help. And I don't mind if you get either. So it's not for marks. And it's going to become a more regular thing. Plus, it's a way for me to do multiple choice with you. Multiple choice is incredibly important, and we never have time to do it. So, Isabella, I'll come back to you as well. Oh, wow. We do need to do work. It's a way for me to do multiple choice. It's a good way of testing the multiple choice because we don't have time in class. Isabella, there will still be cycle tests, but it won't start until a couple of weeks back. So the first couple of weeks, there won't be. Isabella, no, we're back in term 2, as far as I know. I'm not really sure how all of that's going to work. There are some subjects that need you to do another cycle test and another class test for your SBA. Okay, so that hasn't been taken out. They have to be done. I am going to be asking for a cycle test and a couple of class tests as we go along because I think it's, and for me, it's about getting used to writing under exam conditions again. It's been a very long time since you've had to get into that role. Okay. If I am reading, and this is a big if I'm reading my ATPs correctly, we are done with your science SBA. I don't actually have to do anything else. I don't have to do the 2 pracs I thought I had to do. Which I think is right, because social distancing would have been an issue with those. So if I'm reading it right, we're not having to do anything. I know there's other subjects that still need cycle tests and that sort of thing to go on, and they've got to catch up some term 1 cycle tests that didn't get written because we left early. Okay, so, but it won't be the first couple of weeks. We first making sure that we can get into the run of things, getting you into class, getting you having your temperature taken every day, and putting your parents' mind at rest that we can do this. Okay, so with the assignment. I'm hearing, yes, who's this?
It's Kaylin.
Hello, Kaylin. Yes, sweetie.
Hi, ma'am. I just wanted to know if someone has like a really high temperature, they're just going to send them home.
No. If you have a high temperature, we have to have an isolation room. And also with we have to have an isolation room. The school's actually working on employing a full-time medic. So what you won't be seen to by the first aid, but by the medic, who will then look after you basically until we can go get you tested, or your parents can fetch you, or something like that. But we have to have an isolation room, and it won't be the sick room. The sick room's too small. Okay, so you will be put in isolation. Does it help you, Kaylin?
Yeah. All right. Thank you.
You're welcome. Luca, heaven forbid you see me. Hey, sorry, she wants some love. She'll say hello now. Luca, how long before the other grades come in? We're not sure. We're waiting for the department to let us know. See, she's like you guys today. Say hello. Hello. All right. Of course you're going to eat at school this year. We've got to work. No. Hopefully in 2 weeks' time, we'll definitely be able to bring the grade 11s in. We're not sure after that because it's a space thing. Nasir, there will be no tuck shop. You have to bring your own food. And as long as you're social distancing, it's okay. You can eat at school. All right. Could you imagine if they wouldn't let me drink coffee because I have to have my mask on all the time? I will die. You will die. It won't be pretty. Yes, Luca, it will. That's why we're not putting we don't have any dates for the rest of the school. Okay, right now, priority is you guys. Once we've got that right, we'll look, and it depends on what the governments and the union say. All right. For now, can we eat in class? Like now, like today, while I'm busy, absolutely up on my coffee. I can't see if you're eating now. When you go back to school, no, because masks have to be on all the time. Okay. Now, we're going to do some work. Normal amount geometry, we're moving classes. Okay. The classes are set up. You won't be in my lab. You'll be in another classroom. I don't actually know where I'm going to be teaching. You'll be told. But we're not changing the class sizes unless we absolutely have to. Okay. Man, sorry, guys. She really is having a moment. Anyway. You must bring your own, Kaylin. You really must bring your own. The school got a very limited supply of disposable masks, but you must bring your own. Okay, you must be wearing your own. You should have anyway. You're not allowed to go anywhere without them. Just going to put it. I teach with a face shield. I got given a face shield. So I'm going to have a little bit of a... Gemma, this is the last question. Okay. I actually asked that question today to Mrs. Pierce because someone in my department brought it up. We don't know. Okay, there are so many issues around your locker that we honestly, I'm sorry, I'm just gonna leave you to see my cat. I don't know, sweetie. The exec and stuff are still talking about it. Okay, I can't answer that one for you. Anyway, so last week I'm gonna do this because a certain cat has decided she owns the house. I gave you the activity and now we're going to mark it. I know some of you haven't done it, but let's just go there anyway. So we're going to mark the activity that I asked you to do last week. Okay. Which is here. No, that's you guys. That's where's it gone? I said to you, I wanted you to do activity 3 on page 331. I just wanted you to do question 1 and 2. So we're going to look at that quite quickly. Luca, I haven't finished all the memos yet. Okay. So, but I will put the memos for the next 2 activities into the files. Okay. I don't want to put them in too far ahead of when we do them. Okay. But I will put them in. Don't worry. So here we go. What is the energy of a photon? I wanted you to do question 1 and 2. So we're going to do this really, really quickly. They gave you the frequency of light. So for question 1, they told you they gave you frequency. That makes this very easy. So this is E equals HF. They want, the point is to remember that this is 6,63 times 10 to the minus 34. The frequency was 4,6 times 10 to the 14. You put it in your calculator, 3,05 times 10 to the minus 19 joules. Okay, so that was nice and simple. Same with 1.2. It's exactly the same concept, but now they gave you 6,9 times 10 to the 14 for the frequency. So we put it in. Nice and simple. All right. And there's our answer. Please, guys, remember you need to be careful with your rounding off. All right, 2 decimal places. If you want to have more than that, I guess it's really not a train smash. But rather keep to 2 decimal places. It will make your life a little bit easier, okay, in the long run. And that's really, really, really what we want. Okay. All righty. So here we are. Then question 2, they changed things a little bit here. Okay, so for question 2, what they did is now they gave you wavelengths. Now I'm not going to do all of these because it's the same thing over and over again. Okay, so I don't want to do the same thing over and over again because it gets a little boring. Let's just be honest. And I will be putting the memo up. So 2.1, they told you that it was 1,500 nanometers. That was the important thing here. They gave you wavelength. Remember, nano means you've got it times by 10 to the minus 9. All right. Don't worry. I know that this isn't proper scientific notation. I understand that. Okay. But it's not important. Okay, that proper scientific notation here really is not important, so don't stress about it. What they wanted you to realize with question 2 is you're going to use HC over lambda, and that's for the whole of question 2. Okay, the whole of question 2. So here we're going to have 6,63 times 10 to the minus 34. That's a given. C is the speed of light or the speed of electromagnetic radiation. That's 3 times 10 to the 8. So the top of this equation is a constant. That's not going to change, all right? The bottom is now 1,500 times 10 to the minus 9. And we get 1,33 times 10 to the minus 19 joules. And in fact, I'm not going to do any of the others. I'm just going to look at 2.4 though. If you look carefully, for those of you who have done it, and you look at all your answers, all your energies come out to something times 10 to the minus 19. Very normal, tiny, tiny, tiny values, okay? I want to look at 2.4 because here they now have it in picometers. And that's the only thing I want to see here, right? So wavelength is 154 picometers. Pico is 10 to the minus 12. That's the only difference. So it's tiny, 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 tiny. Okay. But you still get, oh wait, no, this one you get you get a slightly bigger energy. Okay. In fact, the last two you get slightly bigger energies, and that's fine. So if we're gonna go E equals HC over lambda, 6,63 times 10 to the minus 34, 3 times 10 to the 8. Now this is 154 times 10 to the minus 12. Grade 12s is probably a good idea for this section to have your calculators in scientific notation. Okay, you're going to work with scientific notation with a lot of these. And we get 1,29 times 10 to the minus 15. It has more energy because it's a smaller wavelength. If it's a smaller wavelength, it has a bigger frequency. If it has a bigger frequency, it has more energy. Okay? So, the point now is this. We've now done, and I'll put all the answers up for you, I will. So we've done a little exercise where we've looked at how much energy photons have, but there's got to be a point to it, because we've spoken about how the electrons can be taken off the metal, okay? And it's all the energy that the photon has gets transferred to the electron, okay? Now, work function is very important, because what the work function does, so we're here, okay, so we're on the photoelectric effect. This is where we ended off last time, so we're here. What's important to remember, there's actually a couple of, there's three things that can happen when light hits a metal. The first is the electrons are not given off. The second is that all that happens is that the electrons go to the surface of the metal. And the third is that the electrons leave the metal and have a velocity. Okay, they have a speed. So when we look at, and this is a very typical type of diagram that you'll see, we have our valence electrons. The red part, that is your nuclei with your core electrons, okay? And some people are leaving me. I can see that. It's great. I just need you guys to know that I'm able to take a register that tells me exactly when you left my meetings or whether you joined at all, just so you know, okay? And my cat has decided she wants to sleep on my computer. And she's turned my screen upside down. Moving on. So, I just need you to know that. I'm going to have to do something else to get... Anyway, guys, at the moment, I actually can't see the chat because of what my cat's done. So, if you need to ask me a question, just put your mic on for me, okay? Because right now, I can't see squat. She's done weird things and I can't use my computer. Moving on. So, core electrons, nuclei and the core electrons, those can't move. These are the delocalized electrons. They're on the outer shell. They're free to move. This is how we represent a photon. Okay, so this photon, this is light that's now hitting the metal. Each photon interacts with a electron. If there's sufficient energy, it can come off. All right, so we get a maximum kinetic energy. But it's only going to come off and fly away if we have energy greater than the work function. So now watch. We have an equation. Now over here, this equation, okay, so the equation I've got here shows me a relationship. You are given this equation. Okay, so you need to know you will be given this equation. E, this one here, is energy of the photon, the actual photon that's used. WO, work function. Okay, so that's the work that's the energy, that the minimum energy needed to release the electron. If E, okay, so if the energy of the photon is bigger than the work function, there's energy left over. That leftover energy causes the electron to move. So now my electron can move from one point to another. Okay? By it being able to move from one point to another, okay, we get kinetic energy. But we know that we don't always have E and we don't always have the work function. So we can change that to be an HF, the equation we've just worked with. HFO, in other words, finding the work function if I know the cutoff frequency, the threshold frequency, okay? And then you know the equation for kinetic energy. You've seen that one before. That's not an issue. You have seen that equation before, so don't stress about it. And then if we don't have frequency, we can use wavelength, okay? This mass, and I need you to be very important, make a note here, this mass, okay, is the mass of an electron, okay? It's the mass of an electron. Very, very important thing. So this mass is a constant, okay? It's a constant. Very important, okay? It's a constant, and it happens to be 9,11 times 10 to the minus 31 kilograms, okay? Very important. Nice thing is you don't need to write down, so you don't need to learn this constant, okay? You do not need to learn this constant. It's a given. It'll always be there, okay? I think I might have missed some chat along the way. Let's just see. Is there, like I said, it's upside down. So Electra, you're asking me, is the mass only for the equations with wavelength or for both? It's for both, sweetie. So whether you've got the wavelength or whether you've got frequency, it doesn't matter. The mass is the same. What we're looking at here is this kinetic energy is the kinetic energy of the electrons that are given off. Okay, and what they do is they call those photoelectrons. Okay, don't worry about the term photo. It's just because it's given off. Ma'am, please explain the diagram again. All right, so Isabella, and I'm sure you weren't the only one. This is the photon of light. So this is light that's pushed onto the metal. It comes along. These electrons here, these blue ones, those are your valence electrons. So those are the electrons that are free to move. They're in the outer shell. They're not held on tight. If this photon has frequency that is equal to or above the threshold frequency, all right, it can kick the electrons out. If it is just threshold frequency, the electrons literally just sit on the surface. If it's above threshold, then we get extra energy that can come off. All right. So then what that means is that the electrons now have a kinetic energy and they'll have enough energy to speed away, which is actually what we want. Threshold frequency isn't useful. We need to have a frequency that is, how do I explain? We want a frequency that's above threshold because we need the electrons to have energy to move from one point to another. Okay, that's really important here. Okay, so if we look at an example, the work function of silver, when we do it, yes.
So for that, the velocity of the in the kinetic energy of the photoelectron.
Yes.
that velocity depends on how much excess energy there is after it's been knocked off.
Yes. And am I talking to Michael?
Yes, ma'am, that's me.
How good am I? Absolutely correct. Michael? Oh, look, it shows. No, you're 100% correct. So there has to be excess. Whatever isn't there can make it move.
Okay,
Does
so
that help? Yeah.
that velocity will change depending on how much energy the photon has coming into the surface.
Absolutely. So if we increase the frequency of the light, then we can make the electrons go faster. Yes.
Okay, thank you, ma'am.
Okay, you're welcome. Good question. All right. So let's go back here. They told us work function of silver. So this value there is WO. And then they say to show that the cutoff frequency is very, very important. They want you to prove what the cut. Oh, yes. Who am I talking to? No. Michael's mic came on and off. Okay. Please be careful with these questions, grade 12s, because you're very likely to want to use both pieces of information. It's not what they asked. Okay. Because you have to show that the cutoff frequency is this, you must work out the frequency for the threshold work function, and then compare it. Okay. So WO is HFO. We're going to use the work function that was given to us. Okay. And then we're going to work out what frequency should be. And actually, I should have put a little 0 there. And we get 1,13. That's close enough. All right. Because this didn't have 2 decimal places. It's fine. Exactly what they wanted you to work out. Okay. So that's fairly straightforward. Okay. You all happy with that, I hope? Then, now we're going to use the equation. So now it says to you, electromagnetic radiation of frequency. Guys, it makes no difference what the electromagnetic radiation is. So this could be gamma rays, this could be infrared, this could be, I don't know, all sorts of things. It's irrelevant, okay? That doesn't matter. It's part of the spectrum. Because it's part of the spectrum, that means that we can get the photoelectric effect happening, maybe. Okay? So, incident on sodium metal, the emitted photoelectrons, all they're saying here is the electrons that are given off have a kinetic energy of 1,6 times 10 to the minus 18. That is EK. This is F, straight F. It's not threshold, okay? That's really important for you to get here. It's not the threshold. And I want you to see the difference. If it was threshold, then they would have to tell me it's the threshold, okay? But they don't. They tell me that it's the actual frequency. So this value is going to be used to get E. I don't have WO, okay? And it doesn't matter because actually they want you to get the cutoff frequency. Remember, WO is HFO. I know H. That's why we get the equation in so many different forms. So watch. E equals WO EK max, okay? They didn't give us E, but because I know F, I can work it out. I want the threshold frequency, and they told me what E max is. So this is a straightforward substitution, okay? Now, I really should have over here, I realized it could get a little complicated for you guys, is that this could also be written as 6,63 times 10 to the minus 34 times FO over here instead. Okay, I could have done that. After that, it's a maths problem. All right. So after that, it's a maths problem. This here is that answer. All I've done is taken the kinetic energy over to the left-hand side and swapped the two sides around and then solved for FO. Okay.
Ma'am,
Yes?
where did you get the 1,989 times 10 to the negative 18?
Okay, that's Electra. It's here, sweetie. I'll do another color. Here's the blue. It's this. It's the answer to that value. And that is HF, where the F was given to you as the frequency of the light.
But ma'am, that number is still underneath. So then where?
Oh, because I've swapped them around. I did all the maths. What I should have written it like this first, okay, sweetie? This is actually I did the maths in one step when I shouldn't have. No, I think I know where I've confused you guys, and that's fine. Sometimes I forget that I'm quite horrible with these. So if I didn't write that sum, okay, but wrote it like this, I would have. This is what the next line would have looked like. And of course, I was given that 1,6 times 10 to the minus 18. That line there is the next step in the maths. So I sort of just skipped a step. Does that help, Electra?
Yes, thank you, ma'am.
You're welcome. I'm pretty sure you weren't the only one who was like, what? I know. I sort of skipped a couple of steps. Sorry, guys. I get excited. It's a maths thing, you know. Remember, I don't really care about seeing your maths. I just want to see the substitution. That's actually the important part. And then solving for FO. So they wanted the threshold. Okay. Now, what this means is because, let's use another color, because I have a kinetic energy, these electrons have a speed. They will move from one side to the other. Okay. Which is actually quite nice. So they'll move from one side to the other and they'll just keep moving because they have a kinetic energy, and kinetic energy is a half mv squared. I could ask you to work out the velocity because we know what the mass of an electron is because it's given. Okay? So we're all sort of good with that, I hope. And I know I was horrible about the maths. Oh, Karen. Oh, okay, I'll come back to Karen. Karen got kicked off. All right. So, now, when it comes to frequency, sorry, ma'am, Isabella, did I not answer that? I think we missed it. The 1, okay, so this 1,89, I think we'll do this again. It's all right, Isabella. The answer to that sum is 1,89. I just did all the maths. I did it all in one step instead of doing it on the other side. Okay, Isabella, I hope that helps. I really shouldn't have done that. Sorry, guys. All right.
Ma'am.
Somebody's got a question? Yes, sweetie.
Sorry, no, I mean the 6 times 10 to the negative 18, not
the
the 1.9.
That one. Okay.
Yeah.
That was given. If you go back to the question. Okay, so we go back over here. The question is, yes, got it. So give me a second. There's the question. If you look at the question, okay, over here, Isabella, they told you that the energy was 1,6. Sorry, my screen's upside down. Is that better, Isabella?
I'm just trying to understand the equation itself. Is it just subbing in to that first equation, the E equals WO, or I think that's what I'm confused about.
Okay, no, you won't be the only one. We're actually using, let's go back here, we're actually using a version of this equation, this long equation. So what we've done, because there's kinetic energy, we're actually using that equation where we've got enough information to find the energy of the photon, we have to find FO, and they gave me Emax. So it's substituting into this long equation. It's not into just the simple equation. Okay. Does it help, Isabella?
So is the 1.6 times 10 to the negative 8, is that the in place?
Yep. It's in place of Emax. Yes? Did a little light bulb go on?
No, I'm
Sounded
still a
like
little bit confused. I don't know why. It's the equations are confusing me because I understand where the HF and the HFO
Yeah.
is. But then
because
if you had to use that long equation, it would be plus half mv squared.
MV
I think that's why I'm
squared.
confused.
But a half mv squared is kinetic energy, and they gave you the value of the kinetic energy. They told you
Okay,
the
that's why I'm
value of it,
confused.
so you didn't need the mass and the velocity. Okay,
Okay, yes, I see.
we good.
Thank
All
you.
right. You're welcome, Isabella. Somebody else? Yes, who's that?
Jared, ma'am.
Yes, Jared. How can I help you, sweetie?
How did it go from a positive then to a negative?
Because I swapped things around. So if you look at it, and I know I'll write it out again before we move on. So what I've done, okay, is I skipped out a math step. So let's take this out. And so what I did is this line here is where things got a little kooky for you guys. I think that's where I lost you. What I should have written is, because I just skipped a step. So it would have been that equal to 6,63 times 10 to the minus 34 times FO plus the 1,6 times 10 to the minus 18. But if I want this on its own, then I need to minus this on both sides. So it's when I took it over to that side. So probably if I'd written it this way around, it would have made more sense. I think that's where I lost you guys. And then I can solve for FO. Does that help, Jared?
Okay, yes, ma'am. That's better. Thank you, ma'am.
Yeah, that's exactly where I lost you, is the way I did the math. So don't stress about it. All right, guys. Our time is up. I'm glad we get so much work done. I'm not going to go any further than that. I'm not going to give you any work to do other than please, 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 I'm begging you, please do the assignment. Okay, please go look at it. I know that for a lot of you, or maybe I should put my camera on. I know for a lot of you it freaks you out a little bit, but it really is about me knowing how you're doing. Okay, and I will go back and relook at all of it and remark what I need to. There is a cutoff time. I would like about 2 o'clock today, but after 2 o'clock tomorrow, you won't be able to hand it in. Okay, it will be over. It won't let you. All right, but we're done, and I will see you guys on Thursday. Okay, keep well, guys.
Bye, ma'am.
Bye, Gabby. Hang in there. Bye, guys. Now I can turn my screen the right way around. It is upside down, which is beyond me. Have a good day, guys. Okay. Let's cut it out again. Ish. Okie dokie. Okay, I think you guys are all saying goodbye, but I can't see because my screen's upside down. Let me have a look here. Let's go look to the chats. Stop